Hello students, good evening. So in this lecture I am going to explain about diode current equation. ये diode current equation क्या होता है? इससे usually MCQ kind of question मिलता है, नहीं तो short numerical मिलता है. Diode current equation क्या है? Diode current क्या होता है? Diode current is a current which will flow through the diode at various circumstances or various condition during forward biased and or reverse biased. Again I repeat, diode current tells us the current flowing through the diode, flowing through the diode, ये हो गया definition, flowing through the diode, okay, during forward bias or reverse bias at certain condition, at certain condition. So what are the certain condition? That condition is how much apply voltage you are giving to the diode. So what is the junction voltage due to temperature, and what is the reverse saturation current, right? And what is the ideality factor? The ideality factor for germanium it is 1, for silicon it is 2. So let us analyze, or let us analyze this equation. Diode current depends on 4 फैक्टर. रिमेंबर, मैं शॉर्टकट बोल रहा हूँ. डायोड करंट का इक्वेशन जो है, that equation will be coming in terms of exponential function. But first to understand, diode current depends on, the first is reverse saturation current. Reverse saturation current at room temperature. Reverse saturation current at room temperature. रूम टेम्परेचर कितना है? 300 केल्विन. रिवर्स सैचुरेशन करंट का सिंबल क्या है? आई नॉट. डायोड करंट का सिंबल इज आई. एंड सेकेंड इज इट डिपेंड्स ऑन योर एक्सटर्नल वोल्टेज और अप्लाइड वोल्टेज. एक्सटर्नल वोल्टेज, और यू कैन से अप्लाइड वोल्टेज. अप्लाइड वोल्टेज, it is denoted as V. If V is positive, it is forward bias. If V is negative, it will be reverse bias. Clear? And third is most important. It is depends on the voltage across the junction at a particular temperature. You can say it is thermal voltage. Which voltage? Thermal voltage. It is denoted as VT. V capital, V suffix T. Thermal voltage को you can say like volt equivalent of temperature, right? Volt equivalent of temperature. Next is it depends on ideality factor. Ideality factor एक constant होता है, that symbol is eta. That eta is 1 for germanium and eta is 2 for silicon. Clear? Again I repeat, diode current depends on 4 factors. First is reverse saturation current at room temperature, which is I naught. Second is external voltage or applied voltage, which is V. It may be forward bias, it may be reverse bias. अगर forward bias होगा V will be positive, reverse bias होगा तो V will be negative. And it depends on thermal voltage Vt. थर्मल वोल्टेज को यू कैन से वोल्टेज इक्विवेलेंट ऑफ टेम्परेचर. ये भी थर्मल वोल्टेज है, इसका भी एक्सप्रेशन है. थर्मल वोल्टेज डिपेंड्स ऑन 2 फैक्टर, लाइक द वोल्टेज डिपेंड्स ऑन टेम्परेचर, वोल्टेज डिपेंड्स ऑन द चार्ज एंड द इलेक्ट्रॉन at that junction, and it depends on the Boltzmann constant, right? We'll discuss this one. And the diode current depends on again ideality factor. It is constant, that value is 1 for germanium, 2 for silicon, right? So let us write this equation. The diode current equation क्या है? So diode current equation is I is equal to I naught whole into e to the power v by eta vt minus 1. Okay. See this equation you have to remember. I am not going to derive this expression because it is not part of our syllabus. But the equation you can get easily. It is an exponential equation, exponential function, right? As you know, the diode characteristics is non-linear. If we plot a graph between voltage and current during forward bias or reverse bias condition, so the graph is not straight line. It is not linear. It is non-linear. So from that graph, we'll be getting this expression. So it is coming in terms of exponential function. So I क्या है, मैंने I बोला था क्या है, डायोड करंट. I is the डायोड करंट. मैं बार बार रिपीट कर रहा हूँ. ये हो गया रिवर्स सैचुरेशन करंट. रिवर्स सैचुरेशन करंट ऑलरेडी मैंने बोल चुका हूँ ये एट रूम टेम्परेचर. ठीक है. एंड ये जो V होता है, V इज द अप्लाइड वोल्टेज. V is the applied voltage, right? ये जो ईटा फैक्टर होता है, ईटा is 1 for germanium and it is 2 for silicon. It is called ideality factor. Ideality factor, right? And VT जो है, ये VT is what? The voltage across the junction at a particular temperature. ये temperature room temperature हो सकता है, नहीं तो more than room temperature भी हो सकता है, right? सो ये जो वोल्टेज को बोलते हैं थर्मल वोल्टेज. क्या है? थर्मल वोल्टेज. देन सो रिवर्स सैचुरेशन करंट इज आई नॉट, डायोड करंट इज आई. ये तो V हो गया. ठीक है. सो नाउ विल डिस्कस अबाउट द थर्मल वोल्टेज. सो ये थर्मल वोल्टेज क्या होता है? एंड थर्मल वोल्टेज डिपेंड्स ऑन व्हिच पैरामीटर और व्हिच इट डिपेंड्स ऑन व्हिच फैक्टर, राइट? ये जो थर्मल वोल्टेज होता है, थर्मल वोल्टेज मतलब ये एक जंक्शन है, ये एक पीएन जंक्शन है. ठीक है. ये एक पीएन जंक्शन है. व्हाट इज द पोटेंशियल एट द जंक्शन ड्यू टू टेम्परेचर? ड्यू टू टेम्परेचर. सो ये VT थर्मल वोल्टेज is directly proportional to temperature and it is inversely proportional to the charge on electron, right? So that means we can write down VT is proportional to T is proportional to 1 by E or 1 by Q. Q is the charge on electron. So we can write down VT is proportional to T by Q, or we can write down VT is equal to some constant K T upon Q, right? K T upon Q. K क्या है? Boltzmann constant. T is the temperature. Q is the charge on electron. So that means finally we are getting the expression of expression of VT as what? KT upon Q, right? So if we'll put that value here, so the value of K is what? K is Boltzmann constant. मैं लिख रहा हूँ इधर देखो, Boltzmann's constant. What is the value of Boltzmann constant? I think it is 1.38 into 10 to the power minus 23. And you know charge on electron is 1.6 into 10 to the power minus 19 coulomb. Right? T is the temperature. T is the temperature. So here if I put the value, K value is 1.38 into 10 to the power minus 23 upon charge on electron is 1.6 into 10 to the power minus 19 into T. So ये जो पार्ट है देखो 1.38 upon 1.6, I think it is coming 0.86 into 10 to the power minus 4 into T, right? So 0.86 upon 10,000, we can say 10,000 into how much? T, right? So it is coming, you can say it is 0.000086 into T, right? So directly you can instead of using that instead of putting that value in this equation in the numerical, the best way, मैं एक चीज बोल रहा हूँ याद रखो, it is a trick. VT is T by 11,600. याद रखो ये चीज. तुम बोलोगे कैसे सर हो गया? अरे अगर हम लोग ये वैल्यू पुट किए, कितना मिल रहा है? 0.4086. देखो 0.4086 विल बी 1 by 11,000. अरे ये जो वैल्यू है इट इज कमिंग 1 by 11,000 नियरली, राइट? सो बेटर यू रिमेम्बर दिस वन. द VT यूजुअली स्टूडेंट क्या करते हैं, आई हैव सीन स्टूडेंट यूजुअली वैल्यू पुट करते हैं, VT का एक्सप्रेशन लिखते हैं KT upon Q का वैल्यू पुट करते हैं, K का वैल्यू पुट करते हैं, देन इट विल बी मोर क्लमजी एंड इट विल टेक मोर टाइम. So better you remember the Vt is nothing but T upon 11,600. Right? It is clear? Okay. Now the point is, now the point is, at room temperature, what is the value of I in forward bias condition? See, room temperature मतलब T is equal to 300 Kelvin. So यहाँ पे डाल दो. So Vt will be 300 upon 11,000. डबल जीरो कैंसिल हो गया. So it is coming 3/116. Clear? So मैं इरेज करता हूँ पार्ट. 3/116 याद रखना. ठीक है. So मतलब at room temperature I will be I naught whole into e to the power v by eta into कितना था 3/116, right? Here minus of how much 1. So I can write down here I will be equal to I naught whole into e to the power 116 by 3 यहाँ पे v into eta and minus 1 is there. So 116 by 3 is approximately 40, 39 point something. You take it 40. So the expression of I is I naught whole into e to the power 40v upon eta minus 1. ये v यूनिट नहीं है, v is the voltage. So ये हो गया आपका diode current in the forward bias condition at room temperature. It is clear? It is clear? So that means we are getting expression of current as I naught whole into e to the power 40v upon eta minus 1. So for for germanium atom, what is the value of eta? Eta is 1. So what is the value of I here? I is I naught whole into e to the power only 40v minus 1. So directly you can put this formula for germanium atom. If it is silicon atom, so eta will be 2. So your current will be I naught whole into e to the power 20v minus 1. इसमें डाल दो 2 डाल दो. It is clear? It is clear everyone? Okay. ये हो गया आपका the current through the diode at forward bias condition at room temperature. But most important is reverse bias condition. Okay, is it visible? Let me थोड़ा इंक डाल रहा हूँ. Just a minute. अरे इंक खत्म हो गया. मैं डाल रहा हूँ इंक. ठीक है. Now it is visible. It is visible. थोड़ा इरेज कर लेते. कर्लिंग यूज कर रहा. नहीं तो ये व्हाइट बोर्ड एकदम हो रहा है. I think it is visible. Yeah. Okay. So we'll talk about the reverse bias condition. Reverse bias condition में voltage क्या है? Negative. Your applied voltage will be negative. Expression क्या है? Current का expression is I is equal to I naught whole into e to the power minus v upon eta Vt, because v will be negative here. minus 1 here. ये हो गया रिवर्स बायस कंडीशन में करंट का इक्वेशन. बट यूजुअली क्या होता है, ये जो जंक्शन पोटेंशियल और जंक्शन वोल्टेज एट द टेम्परेचर यूजुअली कम होता है विथ रेस्पेक्ट टू योर सप्लाई वोल्टेज. or applied voltage. So that means if applied voltage is very greater than Vt, a condition है. Usually you can take this expression if V is very greater than Vt. So this part will be approximately 0. Right? So your I will be equal to I naught into minus 1. So I is minus of I naught. Right? So ये कैसे 0 हो रहा है देखो, very simple. See, e to the power minus v में एक्सप्रेशन लिख रहा हूँ इधर, दिखाई दे रहा है, e to the power minus v upon eta vt. ठीक है, so I can write down 1 by e to the power v by eta vt. Yes or no? ठीक है, so मैंने क्या बोला था, v is very greater than vt. देन ये पार्ट बहुत ज्यादा हो जाएगा, मैक्सिमम हो जाएगा. ईटा का वैल्यू तो कांस्टेंट है, इट मे बी 1 और 2. सो ये वैल्यू भी इंक्रीज हो जाएगा. अगर ये वैल्यू इंक्रीज हो रहा है, e टू द पावर दिस वैल्यू विल बी अगेन इंक्रीजेस. सो 1 बाई ए बिग वैल्यू विल बी वेरी स्मॉल वैल्यू. ये जो वैल्यू बहुत ज्यादा होगा. सो 1 बाई बिग वैल्यू विल बी ए वेरी स्मॉल वैल्यू. So that value is nearly equal to 0. That's why you can neglect this part. So I will be coming minus of I naught. So ये जो current है, that current is reverse saturation current. And most important, याद रखना, and it is valid up to the voltage, up to the applied voltage below your general voltage or breakdown voltage, below the breakdown voltage. ठीक है, so that is all about diode current equation. Clear? Okay, so now we'll solve some numerical based on the diode current equation. ठीक है, यूजुअली क्या होता है देखो, I का एक्सप्रेशन याद रखना, I नॉट होल इनटू e टू द पावर माइनस v बाय eta vt, राइट, माइनस ऑफ 1. ये vt का वैल्यू इज नॉट गिवन. यूजुअली टेम्परेचर विल बी गिवन एंड ये vt इज नथिंग बट, याद रखना, vt मैंने क्या बोला था, t अपॉन 1 11,600. दैट्स ऑल, इतना याद रखो. अप्लाई वोल्टेज विल बी गिवन टू यू and eta will be given to you, whether it is silicon or germanium. So you need to, I naught will be given to you, have to find out I. और कोई भी पैरामीटर देखो, there are various parameters, so except one parameter, rest of the thing will be given to you. You need to find out the unknown parameter by putting this equation, right? So एक numerical करते हैं देखो. Okay, see this example. It is given the reverse saturation current at 300 Kelvin of PN junction germanium diode is 5 microampere. Find the voltage to be applied across the junction to give current of 50 ampere. So here the reverse saturation current is given. I naught is given, which is 5 microampere. That is 5 into 10 to the power minus 6 ampere. Clear? Okay. And your temperature is given 300 Kelvin. Okay. And what is the applied voltage? We have to find out, and your diode current is given, which is 50 milliampere. That is 50 into 10 to the power minus 3 ampere. Clear? So you have to find out V. So इसके लिए मैंने क्या बोला था, मैं इरेज कर रहा हूँ. What is the equation? What is the equation? This equation is I is equal to I naught whole into e to the power V by, क्या बोला था, eta vt, yes or no, minus of 1, right? But here I naught is given. ठीक है, so since it is germanium atom, what is eta? Eta value is 1. So मतलब eta is given and I also given. I is given how much? 50 milliampere. I naught is given how much? 50 microampere. Eta is given. You have to find out the applied voltage, but Vt is not given. बट टेम्परेचर इज गिवन. मैंने क्या बोला था, Vt इज नथिंग बट, मैंने क्या बोला, Vt का फॉर्मूला याद करो, Vt इज T अपॉन 11,000, ये याद रखना. Otherwise, you can put this formula that Vt is equal to it is nothing but K into T upon Q. K का वैल्यू डाल दो, Boltzmann constant, that is 1.38 10 to the power minus 23. Q का वैल्यू डाल दो 1.6 into 10 to the power minus 19. Then T का वैल्यू डाल दो 300 Kelvin. Then you can get the value of Vt. Unnecessary, it will take time. मैं बोल रहा हूँ unnecessarily it will take time. So better you remember the value of Vt. Vt is nothing but T by 11,000. Then T is given how much? 300 Kelvin. You can find out the voltage, right? Clear? I think the answer you calculate and write in comment box. You can calculate. Shall I calculate? Shall I calculate? Unnecessary, it will take time. You calculate. मैंने तो concept बोल दिया. I have explained the concept nicely. You do the calculation. That is your job. Okay, coming to the next question. ये question देखो, ये very easy question. It is all about a comparison. See, calculate the ratio of current for forward biased of 0.06 volt to the current for the same value of reverse biased applied to germanium PN junction diode at 27 degrees Celsius. First thing, germanium atom is given, matlab eta is 1, right? 27 degrees Celsius matlab temperature is 300 Kelvin. ठीक है. So here we'll have to compare between two currents. One is I1 in forward bias condition, second is I2 in reverse bias condition. I का standard expression क्या था? I naught whole into e to the power v by eta Vt minus of 1. Yes or no? So what is I1 by I2? I1 मतलब current in forward bias condition. I2 is current in reverse bias condition. So it will be how much? I naught, दोनों का तो saturation current same होगा. I naught whole into e to the power क्या है, v by eta Vt minus 1. रिवर्स बायस में क्या होगा, इट विल बी e to the power v by eta Vt minus 1. बट डिफरेंस इसकी, ये v जो होगा पॉजिटिव, मतलब ये जो v होगा 0.06 वोल्ट, बट ये जो v होगा माइनस ऑफ 0.06 वोल्ट. दैट इज द डिफरेंस. ठीक है, बाकी सब तो कांस्टेंट है. यू कैन पुट द वैल्यू, right? You cannot cancel this two because it is e to the power something. Don't cancel it. In one case, in here v is 0.06 volt. In forward bias में voltage 0 पॉजिटिव होता है, मैंने बार बार बोल चुका हूँ. रिवर्स बायस में वोल्टेज क्या है, नेगेटिव, माइनस 0.06. My sincere advice to all of you, don't cancel it, otherwise you will be getting one. I1 will be I2. ये आंसर डिफरेंट मिलेगा. ठीक है, यू कैलकुलेट इट एंड ये कमेंट बॉक्स में लिखो आंसर कितना है, आई विल चेक इट, राइट? ठीक है, सो इट इज क्लियर. और भी एक क्वेश्चन करते हैं, देखो. ओके, ये क्वेश्चन देखो. ये क्वेश्चन क्या है, a certain diode reverse saturation current is 15 microampere at 25 degrees Celsius. When it is applied, forward biased voltage is 0.8 volt. Calculate the forward current. I repeat it again. One diode is given, इसका reverse saturation current is given 15 microampere. मतलब I naught is given 15 microampere. That is 15 into 10 to the power minus 6 ampere. But here current is not room temperature. Sorry, temperature is not room temperature. T is here 25 degree Celsius. मतलब 273 plus 25. I think it is 298 Kelvin. ठीक है, and we have to and it is applied FB. FB मतलब Facebook नहीं, forward voltage. Forward voltage मतलब V is given positive 0.8 volt. We have to find out forward current, मतलब we have to find out the diode current. Done. डायोड करंट का एक्सप्रेशन क्या है, I is equal to I naught whole into e to the power v by eta Vt minus of 1. Entire part. ठीक है, so it is given which type of atom. It is not given. You can take it germanium. You take it germanium atom. So germanium atom का eta कितना है? Eta is 1. Okay. So I think I naught is given to you. V is also given 0.8 and VT is not given. VT का मैंने क्या फॉर्मूला बोला था? T upon 11600. ये जो T का वैल्यू 298 यहाँ पे डाल दो, ये VT मिल जाएगा. VT यहाँ पे डाल दो, तुम्हें क्या मिल जाएगा? I मिल जाएगा. Done? Clear? Okay. I think almost it is done. So I have explained diode current equation. What are the parameters? The diode current depends on depends. Like we did some numerical here based on the equation. Hope you enjoy this session. If you like my video, please do subscribe my channel. Thank you very much. Thank you.